Hello everyone, this is Timmy and I'm going to be talking about the IUPAC naming of two linkage isomers and the method of characterization that's used to distinguish them. The coordination complex contains ruthenium ion that's centrally coordinated. It has a d6 electronic configuration in its ion state, which gives 6 electrons for bonding, thereby forming an octahedral geometry. In the first ligand, there are two of these pyridine rings in the diagram at the top, each connected at the number 2 position to make them look like this diagram below. Each pyridine ring contains a nitrogen atom with a lone pair of electrons that can donate to a metal center. This way, a bipyridine ligand contributes 2 coordination sites to ruthenium. Since there are 2 of these bipyridine ligands in the structure, it will provide 4 nitrogen donor atoms, which helps stabilize the octahedral geometry around ruthenium. And then 2 and 2' can be used to signify that the 2 pyridine rings are joined at the 2 position on each of the rings. And bis can also be used to signify that there's 2 of these bipyridine ligands coordinated to ruthenium. The second ligand displayed in this slide consists of an ethane backbone bearing 2 sulfonyl groups, each having a phenyl ring. The sulfonyl group is versatile because it can coordinate to a metal center either through the sulfur atom or through the oxygen, which leads to a linkage isomerism. It acts as a bidentate chelate to bridge the metal with 2 donor atoms. For this complex, both sulfur atoms bind to the ruthenium center, which then stabilizes the octahedral complex with 6 donor atoms, including the 2 bipyridine ligands. And then 1 and 2 can be used to signify that each carbon is connected to a phenyl sulfonyl group, and bis is then used to identify that there's 2 phenyl sulfonyl groups, one on each carbon. And then both ligands are connected to the metal center, and for the ligand containing the sulfonyl group, kappa can be used to signify that the ligand is binding to ruthenium through sulfur. Since there are 2 sulfur atoms it's binding through, it'll be denoted as kappa squared S prime. In this diagram, I have the complex drawn out with priority numbers assigned to the functional groups. The sulfonyl groups have priority 1, and then the phenyl groups have priority 2. The axis which should have the highest priority across the lowest possible is identified with the dotted line across. And the group across the highest priority, which is 2, is denoted. And then in the square, the group the highest priority is across from, which is 2, is also denoted to give us the full IUPAC name of OC622 bis 2 2' bipyridine 1 2 bis phenyl sulfonyl ethane kappa squared S prime ruthenium 2 ion. These are the 2 linkage isomers, with the second isomer shown on the bottom right in the slide. The second complex differs from the first, with the oxygen in one of the phenyl sulfonyl groups binding to the ruthenium center instead of sulfur, which will be reflected as kappa squared SO instead of kappa squared SS. This is the complex drawn out with priority numbers assigned to the functional groups. There are 3 different priority groups with the oxygen now connected to ruthenium. The same rules as the first isomer are applied to derive 3 as the group on the same line as the axis, and then the group on the same line as the highest priority in the square complex, being 3, to give the full IUPAC name of OC633 bis 2 2' bipyridine 1 2 bis phenyl sulfonyl ethane kappa squared SO ruthenium 2 ion. IR spectroscopy can be used to differentiate between the 2 linkage isomers. When the sulfoxide bonds through the sulfur atom, the bond is less unsettled, which retains more double bond character and shifts the stretching frequency to a higher wave number of 1040 to 1070. And when it coordinates to the oxygen atom, the sulfur-oxygen bond is weakened due to electron density donation from the oxygen lone pair into the ruthenium center, which lowers the stretching frequency to 1000 to 1020 wave number.